Hello, everybody, and welcome to this first webinar in a series that we called the V2Market Bidirectional Charging of Electric Vehicles webinar series. I'm Andrés Pinto-Bello. I'm the head of research and projects at smartEn, Smart Energy Europe, and I'm going to be the host for today. We have a very interesting agenda where we will be talking everything electric vehicles and the role that they will play in the energy system. So I will introduce our agenda later on, but just as a sort of setting the scene, if you're here with us today, you're at least aware of the services that electric vehicles can provide to beyond taking us from place A to B. So with this series of webinars, we want to underline not only the wide breadth of services that electric vehicles can provide, but we want to highlight the critical role that electric vehicles will play in the coming years in ensuring that we have a stable and secure grid, and that we will also make the best use of the available resources, in particular renewable energies that will be flowing into the grid. We go to the next slide, we see a short summary of the services. So we are now reaching a point where the amount of electric vehicles on our roads and cities will dramatically increase. This will bring a significant amount of challenges for our grids and the system operators managing them. So this is where V2X jumps in. Vehicle-to-X is, if you're not aware, is a combination of services that electric vehicles can provide beyond the mobility services, both to the grid through vehicle-to-grid, but also through vehicle-to-building, vehicle-to-home, to the residents, or to, as we will see, larger buildings like like municipalities that will be presented today as well. So V2Market, or the context of this series of webinars, is a European-funded project where we wanted to showcase all of these scenarios and how we can integrate electric vehicles in a more efficient way in the grid. And over the series of webinars, we will share our learnings over the past 3 years of implementing this project in Spain, and what it can bring us also as lessons learned for the development in other European countries. If we go to the next slide, and the one after that, yeah. So what was V2Market? So it is a project where we tried to use electric vehicle batteries as flexible decentralized energy resources that can increase the system flexibility and increase or improve the efficiency of the grid and the resources that we have at it connected to it. And we aimed also at creating, or at least understanding, what are the right market conditions to truly valorize the capacity of electric vehicles as an active resource. How did we try to do this? Well, first, in the project, as you will see soon, we included all the relevant actors in the value chain, from the technology providers of the smart charging or bidirectional charging stations, to the users, which in this case we will see is the city of Barcelona, but also market operators and energy suppliers and so on. We need to tackle the financial barriers to facilitate access to these electric vehicles. As you probably have discussed with your family and friends, the perception is that electric vehicles are more expensive than the internal combustion vehicle. This is in many cases a myth, but also we need to facilitate, or we have this resource in bidirectional charging that will allow to offset the cost of electric vehicles even more. So not only will they be competitive or with internal combustion vehicles, but they will be even cheaper over their lifetime. And of course, we need to advance regulation to be able to provide all these services of vehicle to grid and vehicle to building to consumers. So these are were the main goals of the V2 Market project. How did we do it? First, to understand through market analysis what are the barriers to create these innovative business models. Then we tried to develop this business case based on what was possible. In this, we tried to create a framework for servitization of electric vehicles and the batteries. So this battery as a service concept. We also try to create energy performance contracts for the integration of vehicle to buildings services. And then we are trying to test this use case. We used 12 bidirectional chargers installed in the municipality of Barcelona. And we also have a pilot with Hola Luz, which is one of our members, that for smart charging directly to the consumer. And then on the exploitation part, we will try to leverage everything that we have learned, and this is part of this effort, and share this with the community, share it with other European countries, and through that also try to create a guideline for electric vehicle owners and aggregators to access these services. If we go to the next slide, well, this is the cycle for your information of vehicle to grid, but we can jump to the next one, where we see the consortium that I've already anticipated, where we have all these partners from the Area Metropolitana de Barcelona, to Nuvve, who is the technology provider, Hola Luz, Antenese, and finally OMIE, who is the market operator in Spain. Now, one of the efforts that OMIE was trying to do, if we move to the next slide, is the creation of a market platform where we could trade vehicle to grid services in the city of Barcelona. However, this is not a reality yet, or this is not a possibility yet in the Spanish framework, legal framework. So there's there's no possibility now to create these local flexibility markets in practice. So we created, or OMIE created, a platform to virtually test vehicle to grid flexibility in the city of Barcelona. And this platform is going to test the fleet that the city of electric vehicle fleet of the city, and how it can help in providing local congestion management services to the distribution network. This pilot or this testing will take place over the next few months and will include Hola Luz as the flexibility provider, Nuvve as the technology provider, and OMIE as the market operator. But like I say, this is still only virtual. This is not a reality in the market, or a reality that we can exploit in the real market, let's say. And this is going to be the main topic for our conversation today. How do we get there? How do we make this a possibility in real life, let's say, beyond just the pilot sites? And for that, I will give you a short overview of the regulatory analysis that we have performed at the V2 Market project. If we move on to the next slide, please. So regulation, and the next one, please. So regulation, like I mentioned, is really the cornerstone to be able to implement this in real markets. The project that V2 Market wanted to propose to implement this in real markets. Actually, the regulation exists. We do have the electricity market design that was approved in 2019. It already sets the framework for electric vehicles to provide vehicle-to-grid services through aggregation to the grid. However, the implementation of this electricity market directive and regulation has been quite slow across Europe. And in Spain, in particular, we have seen that the developments have stagnated over the past few years. These maps that you can see here are a summary of the implementation of different articles into national law that we performed at smartEn. And yeah, this is one of the main issues facing for electric vehicles right now. We don't have the regulatory framework at national level to really exploit this business case. Now, if we move to the next slide, I wanted to highlight the two steps, or how we understand it, the two steps that are important to be able to use electric vehicles as an active resource. The first step is the recognition of aggregators and empowering of consumers. So aggregators would essentially be the actor that will use the electric vehicles and sell their capacities into the grid through various types of service. Now, aggregators are a new figure, a legal figure for many countries. They don't have this framework developed for aggregators, both aggregation in general, but also independent aggregators that are not linked with the supplier. For this, we do have an article in the Electricity Market Directive. This is Article 17, and it sets the basis for the creation of an aggregator framework. This aggregator framework will detail the roles and responsibilities of these actors and will allow them to participate alongside suppliers and any other resources into every electricity market. So this is really the first step that we need. Then the second or part of the first step is also the recognition of or empowering consumers. And there we have, for example, Article 13 and 15 of the electricity market design that allows the consumers to play an active role. They do that through removing any hurdles that a consumer might have from or preventing them to engage with an aggregator that is not their supplier. And it also provides, through Article 15, the framework for recognition of what an active consumer is. So that they are be able to operate either independently or through an aggregator, and that they're able to sell their resources, in this case, the electricity that they have stored in an electric vehicle, into the grid. So this is the first step, recognizing what an aggregator is and empowering consumers. Now, the second step is opening markets to these actors. If we move to the next slide, we have here highlighted the main articles that facilitate this access to different markets. And you see already here that Article 17 is repeated. This is not a mistake. This article is integral to both the recognition of the role of the aggregator, but also in facilitating their access to different markets. And this is crucial because electricity markets have been traditionally, of course, coped with traditional generation resources, and they need to do an effort in adapting for other kinds of resources. And this is also where Article 6 and Article 22, for example, they jump in and clarify this for balancing markets and capacity mechanisms in particular. They need to be designed in a transparent and technology neutral way to allow all kinds of resources to participate in them. And crucially here, they should be allowed either to participate individually or through aggregation. Again, this is a concept that is repeated along many of these articles. And then finally, in the last step is Article 32 of the Electricity Market Directive, and that is we need to provide incentives for system operators, in particular for DSOs, to procure flexibility. So we need to provide them incentives for non-wire alternatives to deal with congestions or structural congestions in particular. If we don't do that, we will face, like I was saying before, an exponential growth of electric vehicles connected to the grid, which will cause issues of congestion, and system operators will have to deal with it through grid reinforcement, installing more cables, substations to deal with it, and so on. And demand-side flexibility, and in particular now here in this case, electric vehicles, can play a role in alleviating this congestions. But for that, we need to provide DSOs in particular with incentives to procure flexibility services. And this is what Article 32 does. It creates a framework where the regulated activities of system operators includes in the remuneration services like demand response, okay, which usually had been the regulated activities of system operators have traditionally been centered around capital expenditure investments or CapEx investments. And with this article, we want to also ensure that that operational expenditures are rewarded, where you would fit in the purchasing of demand-side flexibility, the creation of local flexibility markets, and so on. And this is a bit the framework that we see, or the most important articles to take into consideration. Now, if we move into the next slide, we will see how this is actually done in Spain, which is preventing us from implementing the V2 market project into the markets. So we see that independent aggregator status is recognized by Spanish legislation, but there is a lack of secondary legislation that goes into the details of the perimeter correction of the aggregator and in relation with the supplier, and the rules for transfer of energy that can create a barrier for aggregators to participate. Double charges for batteries, which is something that is an issue for electric vehicles as well, like any other storage, that has been removed. But other aspects like the access to ancillary services is still too costly. They're still designed in a way that they prevent de facto, even if not explicitly, they prevent de facto the participation of smaller resources, even through aggregation. This comes through too large minimum bid sizes, for example, that are just not viable for electric vehicles and other assets like this to access these markets. And on the DSO level, we still do not have a regulation in Spain that would enable the creation of local flexibility markets. And this is the issue also that OMIA was facing, and why we're dealing with this market platform on a virtual manner, let's say. Now, the next steps, if we move to the next slide, there are other aspects that we're still dealing with, and I will not go into to detail with this, but it is important also in particular for the exploitation of this business model in Europe. So we want electric vehicles to be able to provide these services in a very wide, or all across the European Union. And now the network code for demand response and is working on it, and the new revision of the electricity market directive and regulation already set the scene for having EU-wide harmonization of product design and data exchanges. And so we do need to, or this goes into into creation of standards for electric vehicles and the use of dedicated measurement devices or submetering that will facilitate the use of electric vehicles in different markets. So we also need or want to have an electric vehicle, and we will see this in the later presentations, to be able to go out from the factory already type tested, already ready to provide flexibility without having to put up many more hurdles. And for that, we need common data standards that can be applicable all across the European Union. But this is not the main point now that I wanted to make, but rather the next steps. So this is to set the scene. Now we will move on to the first presentation of a series of presentations. We have here with us today Hans de Heer. He's the principal consultant at DNV and the main leading author of a report that we did last year on the topic of V2X, and he will show us the wider learnings of what is going on in the European Union and what are the V2X enablers and barriers. Hans, the floor is yours.
Yes, thank you, Andrés, for your introduction. And as Andrés explained, I will give you a short introduction in the study that we have conducted last year for smartEn on enablers and barriers for bidirectional charging. And the report with all the details you can find on the smartEn website. In this report, actually, we looked into enablers and barriers quite similar to what Andrés just presented for the Spanish market. We took a wider perspective there, looking at several European countries. But let me, now the presentation has its own life. I'm not sure why, maybe everyone can control it, but I would like to start with this page. And I would like to start a presentation where every presentation probably starts, and that is the energy transition. And I think with this audience, I don't need to explain anything about the energy transition, nor about the need for flexibility. And of course, that's where smart charging, but especially bidirectional charging, steps into the market. If we look at this need for flexibility in general, you could say there are, well, three possible options. One, from right to left, is more interconnection. Of course, it is needed. Of course, you may understand that is not sufficient to meet all flexibility needs, especially on a more local level. Then there is the option of storage. And there we see that recently this has been the main focus of many policy studies, also tendering. And there's, for example, a study we reference here indicating that there's a need for 200 gigawatt of storage by 2030 in the whole of the European Union and 600 gigawatt by 2050. But there's, of course, a third option, and that is demand-side flexibility. And you could wonder, well, is that the low-hanging fruit? Of course, I will get back to that. Interesting observation here, of course, is that when we talk about bidirectional charging, it basically combines the two of them. It is, of course, a storage technology. You make use of the battery within the vehicle, but it's typically also demand-side flexibility. It's typically charging typically happens behind the meter, as it is called. So it combines the best of both worlds. At the same time, when we talk about barriers, it also combines the worst of both worlds. We see that it faces both the barriers that storage faces, but also that demand-side flexibility faces. Let me move to the next slide, just to well, show some more figures. If we look at the potential of EV charging, of bidirectional charging, although electric vehicles is still a small portion of the full fleet of vehicles, there's already 35 gigawatt of capacity available in 2022, 2 years ago. When we look at 2030, we already see 350 gigawatts, which already exceeds the number I showed in the previous page, what is needed on EU level. So in theory, the full need for storage capacity can already be provided by the storage that is available on wheels rather than stationary storage. Now, of course, stationary storage is also needed. It's not a matter of which to choose, but it's a matter of allowing both to participate in all organized markets. And there we see there are quite some barriers, and that's also what this study aimed to find out and has shown. And those barriers are, as I explained, related to both barriers for storage and for demand-side flexibility. And so there is limited access, and I already give you here the main conclusions to organized markets and additional revenue streams, because, and we saw the example for Spain, demand-side flexibility cannot access those markets in general yet. At least there are many barriers. Double taxation of stored energy, it has been removed in several countries, but not all. And at the same time, we also see that whenever this storage is behind the meter, so it's combined with local demand, maybe local generation, then it's not that straightforward that this double taxation has been removed. There are also barriers on grid requirements. So the grid codes not always allow vehicle to grid, or at least to its full extent, to be provided to the market. And the final, at least the main element, is on the metering part. Sub-metering or dedicated metering devices is really still uncharted territory when it comes to regulation. And it's also important, of course, for flexibility services. If you provide services, you need to be able to settle those. And it would be preferable if you can use dedicated metering devices. So the embedded meter that you typically see in a EV charger in a wall box. But that is, in most member states, not possible yet. Now, a bit more background on the study that we have performed. Well, I think I already mentioned the objectives as to show what are the main barriers, but also drivers to allow bidirectional charging to participate. The relevance, I think also Andrés already explained that those batteries are idle because electric vehicles, like any other vehicle, they stand idle for 90% of the time or more. So in that sense, they can be used to provide energy services. Also, another study we performed for smartEn the year before has shown also the economic potential of this asset, of this technology. If only 30% of charge points could support this technology, it will already provide by 2030 26 gigawatts of flexible power, and that has large financial benefits for the customers, and not only those that apply that have an electric vehicle, but all customers will benefit simply because wholesale prices will reduce on average. Well, in the study, we applied a framework, and I will show you a short overview on the next slide. So we have been looking at what are now the developments on EVs and especially on EV charging. So we have been looking into regulatory aspects, on policy and markets, and we also have been looking at more technical aspects, so on grid codes and on standards. And again, there we looked at the main barriers. And we have been considering several countries. I will show you the list on the next slide. And we basically looked at what is the level of maturity. So we compared the countries against each other as a kind of benchmark to show which countries are basically leading the pack, which are trailing behind. And we have given that a qualification, a color scheme. I will show that here. First, important to state that there is not a single country that has everything in place and everything ready for bidirectional charging to start delivering. There are barriers to be observed in every member state. And we also included GB, as you can see, Great Britain, and Norway, actually. But some are doing better than others. And in that sense, those that are doing better than others can be seen as a best case, as an example, how to move this forward. So in that sense, it's still a relative scale. And there are still, as I said, barriers in every member state, in every country. But it also shows where those barriers are and what needs to be improved. Now, I will, given the time, not lead you through the details here. You can read it all in detail in the report. I will, however, provide you with the main recommendations and our main conclusions. So when it comes to the storage aspect, the main barrier is about double taxation. And I already addressed that, but I want to emphasize that this is not straightforward when it comes to, well, the demand side. So when storage is combined with demand, with generation, then it's quite complex to actually remove the double taxation. And even countries that have removed double taxation still face barriers when it comes to the demand side on this aspect. The second is fully in line with Andrés already indicated. It's about existing EU legislation, especially Electricity Market Directive, that has not been fully implemented in most, if not all, of the countries considered. Main aspects I want to mention here, grid tariff methodologies, they can be a strong driver. They should be cost reflective. Most countries, they're not, and most countries are still volumetric based, which doesn't provide any incentive to shift load and to use storage in general. Yeah, so that part of the directive has not been implemented yet. When it comes to access to wholesale energy and balancing markets, especially through this aggregation framework, again, most of the countries have not implemented it. Maybe for balancing services, some have, although even for residential segments, that is quite, there are very few, especially wholesale. In general, it's not implemented yet. When it comes to DSOs procuring flexibility, there are only a few countries that are moving to a BAU situation when it comes to procuring flexibility, local flexibility markets. Most member states are not there yet. And finally, smart meters. Yes, many member states have a decent amount of smart meters installed, but some haven't. And especially the topic of dedicated metering devices is, as I said before, still uncharted territory. Number 3 is about basically about economies of scale, because apart from regulatory, maybe technical barriers, there's also an economic barrier that a bidirectional charger is more expensive than a unidirectional. And that bridge can be gapped, we believe, or that gap can be bridged if there's economies of scale. And that can be created if there's demand for bidirectional charging and chargers. And a way to create that demand is by mandating it on, let's say, public fleets, public buildings, to support bidirectional charging in those situations. And then finally, as I said in my introduction, there's quite some focus on stationary storage. There are subsidy schemes. There are also capacity remuneration schemes or mechanisms that provide, financial incentive for at least stationary storage. We recommend that also V2X should be able to participate. In the end, those mechanisms should be technology neutral. It is a storage technology that is, on an aggregated level, quite similar. And this, of course, could also further improve the business case for bidirectional charging if it can also participate in those mechanisms and schemes. With that, I come to the conclusion of my presentation, and I would like to hand it back to Andrés.
Thank you, Hans, for this insightful presentation and this very interesting report. I already see some questions coming up. We will deal with questions at the end. We have a whole section dedicated to that. Please, if you have questions, put them in there's a little questions box at the bottom right. There's the questions and the chat. It's easier if you put your questions in the question box, and then I will make sure that we answer as many as possible at the end with all the speakers, because now we have a series of speakers prepared for you that will actually go into the details of what they can do from the industry side. We have technology providers, we have market operators, and the first one is Xavier Moreau. He leads the strategic developments of Nuvve. Nuvve is one of the partners in V2 Market. They provided the technology, the smart charging technology for the bidirectional charging technology for the site of Barcelona. I will let Xavier go on and present himself if he needs to a bit more. Thank you, Xavier.
Hello, thank you very much. Let me share my screen. Right. So what Nuvve brought to this V2 Market project is its vehicle-to-grid technology, which is basically our GV platform, which enables energy markets and services for vehicle-to-grid, energy optimization and buildings with vehicle-to-building, charging management services, and also ensures the battery is protected. In this project, our aim was to demonstrate that V2X can be a win-win-win-win for all, because thanks to bidirectional charging, you can bring benefits to the grid. The electric vehicles are a buffer for the variability of renewable energy. You can bring benefits to the EV drivers to allow them to drive on fully decarbonized electricity. You can bring benefits to society as a whole by saving on greenhouse gas emissions, carbon from power plants. And you can bring benefits to the consumers with revenues from providing services and savings on their energy bill. And so in the V2 Market project, what we have done is for the municipality of Barcelona, the AMB, we've developed some price optimization on 2 of their sites with where we installed some DC CHAdeMO bidirectional chargers. We developed an onboarding questionnaire to include the vehicles with the right level of information on how they were used and we provided an app to the drivers to input their weekly trip schedule. We developed a model to estimate the availability of the vehicles, the consumption of the vehicles and of the building load, and the overall available capacity in order to be able to do energy arbitrage or to optimize on the energy spot price, both the energy cost of the charging and of the building. And all this thanks to our technology and our platform that also includes an app we call Fleetbox for fleet managers to manage the charging of their vehicles. The second thing we've done is to integrate with markets, with the market operator Omie from Spain. So we developed some integration with the day-ahead market and the intraday market in order to develop some wholesale market services based on bids, which is different than what I've shown you previously on price optimization, because when you make a bid on an energy market, you need to deliver exactly what you've committed to deliver. So it's not only kilowatts, but it's kilowatt hours that you need to deliver in a given time frame. So you have to really control the amount of energy you are going to deliver to be aligned with your bid on the market. The third thing we do is with another partner, with Holaluz, with an energy supplier in Spain based in Barcelona, and also with Omie again. We developed some charging advisory services to help consumers target the best hours for charging their vehicle, but really specific to their use of their vehicle. So it's when we say best hours, it's the hours when the price is the lowest, or the hours when the CO2 content is the lowest. So we had to develop a data pipeline to get the data from Omie, from the smart meters, from Holaluz, and model how it was used. In the V2 Market project, we also researched how to manage this data to ensure that the ownership of the data stays with the drivers or the users that created this data, and to protect their personal data. We used our price forecasting technology on Omie data to feed our energy cost optimization analysis tool. And in a second step, we are going to even optimize not only on price, but also on any local PV self-consumption. Another service in parallel is to optimize the imbalances of Holaluz thanks to the charging of the electric vehicles to improve their sourcing of energy.
Thank you, Xavier, for this presentation of what Nuvve did in the project. Now we will move on to other market participants and how they see the development of V2X in their experience, and they will bring us the wider experience beyond the V2 market case and seeing what Europe is doing. And for that, the first one is Robert Seiler. He is the head of strategy at the Mobility House, and he will answer several questions about business models. And already I saw some questions referring to AC cars, so I think that he will also be referring to that in his presentation. So Robert, please go ahead.
Thank you, Andrés. So I will share and take over. Not yet working. There we go. Do you see the presentation?
Yes, perfect.
Okay, so I will talk about the potential of V2G and the value it creates. It is actually as big as charging costs or even beyond. So we will soon be able to offer a 0-0 offering, which is like charging for 0 emissions and 0 costs. As Andrés has already shown, the storage capacity that comes to our roads and garages through electric vehicles is immense. You have even showed bigger numbers, Andrés, than I show here, but they go into the similar direction, 200 to 300 gigawatt of net power in 2030 connected. The controllable power, on the other hand, on the left-hand side, is low and getting lower in the future with less coal and gas and controllable power. So with the rising amount of renewable energies, we desperately need the storage capacity of electric vehicles. And the advantage there is they are there anyway. They are used about 5% of the time for their primary purpose of driving. All the rest of the time they are idle. They are precise, they are fast, and nobody needs to invest in them except for the driver. So driving a vehicle is going to be much cheaper than in the past. On the left-hand side, we see combustion engine cost for driving, annual cost in euro per year. With an electric vehicle, you already have these costs, even below half of the costs. An electric vehicle which is controlled in a V1G way, that means commercialized unidirectionally in front of the meter in the energy system, you can again cut these costs for driving in half through the benefit of V1G. And as I said in the beginning, we are already beyond actually a 0-0 offering. The value you create with a bidirectional vehicle in the system is bigger than costs for charging, and that creates a unique offering for EV drivers of 0 cost with 0 emissions. The emissions are not only reduced to 0 by the step from combustion engine to electric vehicles, but you go beyond that as well by trading energy, like charging energy when renewable energy is abundant, and discharging and therefore replacing when actually fossil energy would have to produce. You reduce emissions in the system as well. Just some examples that we have performed on the way to commercialization of VGI products. We have performed, I think it's already 6 years ago, frequency containment reserve in the German grid with the official pre-qualification of German grid operators. This is, of course, a pilot project that has happened some 6 years ago and is not yet in scale. But it was an important step to prove that this is also possible with all the technical elements that are between a vehicle battery and the grid. That was successful. Another grid support we performed with Tenet, another German grid operator, where we did redispatch with a fleet of electric vehicles. So Germany usually has a congestion in the central center of Germany. Germany has abundant wind power in the north, which the system can sometimes not swallow. And Germany has a lack of energy in the south. So we had a fleet of unidirectional vehicles in the north charging when the wind is blowing and when the grid cannot really transport that to the south, and discharging at the same time with a fleet of bidirectional vehicles in the south and therefore virtually transporting the energy even through congested grids. And the last example here is where we are on the way of decarbonizing a whole island. It's the Porto Santo, the little sister island of Madeira in Portugal, which had in previous times a lot of fossil generation and is on the way to completely renewable energy. So an island system, as it describes really the word, island system with renewable energy based on wind and solar needs flexibility. And we, together with Renault, have supplied this flexibility in terms of unidirectional and bidirectional vehicles, but also to stationary storages based on vehicle batteries. And there we could, with this little amount of vehicles, already improve the uptake of renewable energy by 15%. With a German university, we investigated that it needs about 500 vehicles on the island to become completely independent and fully renewable. And that's possible on an island with 5,000 inhabitants. So we'll soon be there to create a fully emission-free island. The next step is actually a real bummer. In mid-24, so in a couple of weeks actually, we are launching together with Mobilize Renault the first bidirectional commercial scalable product in Europe, first in Germany and France, and a year later in the UK as well. You have probably seen the vehicle already. It was announced yesterday or beginning of this week actually at the motor show in Geneva. And the product will consist of 3 elements. It's an energy tariff, a smart charging app, and actually in the background the mobility house technology which aggregates the flexibility and trades it in the energy and grid markets of these countries. So we are finally there. The mobility house has worked towards vehicle grid integration for the last 15 years. And finally, the market is here and the technology is here and the regulation is almost here, but we don't care, we still launch. Okay, that's it from my side.
Thank you, Robert. Thank you very much. This is the very good overview of the different kinds of business cases that could happen. And very interesting also this last proposition with Renault, which should also answer this question about electric vehicles that are V2G ready, whether this is a hurdle or not. In our report in itself, we have a list of electric vehicles that are already V2G ready and are already in the market. You can consult it in the report. And of course, more and more will come. And now, as we saw with this Renault case, there will be one. I think it's an AC.
Yes.
Car, right? Yeah.
Yep.
And it is already from the box, from the factory, ready for V2G with the whole capabilities incorporated. This is definitely part of the future that we're expecting to see. And now we're going to hear from another V2G aggregator, service provider. We have Claire Weiller. She's the Director of European Strategic Partnerships and Product from Fermata Energy. Claire, welcome, and the floor is yours. Claire, can you hear us?
Hi, everyone.
Hi, Claire. Yeah.
Can you see my presentation?
Yeah, we can. Please go ahead.
Great. So good morning, everyone. Thank you for the opportunity to present here about Fermata Energy's experience over the last recent years commercially running vehicle-to-grid projects. So I'll talk a little bit about our experience, our customers, markets that we're participating in. And my name is Claire Weiller, so I'm representing Fermata Energy. We are a dedicated vehicle-to-grid technology company and solutions provider. We develop mainly a software platform, but also hardware, partly in-house, to deliver value from electric vehicles while they're parked. So our vehicle-to-grid platform communicates and controls electric vehicles through bidirectional chargers. We have optimization and forecasting algorithms that factor in a number of data points, so including the vehicle users, driving requirements, congestion signals from the DSOs, site load, and various price signals, and computes across all of these opportunities, constraints. The optimal response, both in real time and forecasting for the next 24 hours. So here's a bit of a preview of our customer user interface, but just to present the technology, so everyone has already heard about it. V2G offers a solution to manage EVs that's at the intersection of electrified transportation, of responsive buildings, and energy grids. So we're offering solutions that are win-win, as Xavier said, to multiple stakeholders and participants, notably the utility networks, so grid operators. We're solving critical pain points in their networks. We're giving them visibility into assets that have a lot of potential for them deep into their networks. And then for electric vehicle owners, we're reducing the cost of acquiring electric vehicles by generating revenues and savings from them, from various grid services and local energy management. So about Fermata Energy, it's important to highlight that Fermata Energy has been one of the pioneering leaders in vehicle-to-grid, mainly present in North America, in case you're wondering why you haven't necessarily heard much about our activities here. So it's a company that has been earning recurring revenue from V2G operations across the US for about 4 years now. Why is that? Because we've developed in-house the first UL 9741 certified bidirectional charger in North America. So that was a 15 kilowatt DC charger that was meant for commercial fleet operations. And so that product was launched or was certified in 2020, as it has been operating in the field ever since, bidirectionally across different sites. Recently, we also helped Heliox get a charger through UL 1741 SA certification for usage as a bidirectional charger in North America. So that's the FE20 charger, 20 kilowatt DC charger. And we're the only company that's already working with 3 V2G charger manufacturers, because the third one is the BorgWarner charger that is up to 60 kilowatt, but up to 125 kilowatt. That's dedicated for heavy duty fleets in North America once again. So that one is a CCS one. So we're integrated with internally produced chargers as well as externally produced hardware. And we are keeping on deploying these additional partnerships to bring new charger hardware to our platform. We have also been the only company so far approved in the US to manage battery health and to keep the battery warranty valid during our vehicle-to-grid services. So that has been publicly announced by Nissan, that they trust our operations. So then we have been earning significant revenue from our sites across the country for several years doing vehicle-to-grid. So covering, for example, markets in the Northeast US that are predominantly today focused on demand response services. So utilities in the US tend to be vertically integrated, but it would be a little bit equivalent to DSO flexibility services that we see over here in Europe. So these are kind of customer sites that are different types of customers, both public sector, projects with the federal government, with utilities, at OEM sites, and other kind of other fleet operators. We also cover markets in California and Colorado, where there's very high value from demand charge management, which I'll show an example of later. So demand charges are bill components that are applied to a site based on their peak consumption. So with V2G, we reduce those and we save significant amounts of money on fleets' energy bills. We have lots of sites in development, in the pipeline, and yeah, so I'll talk a bit about those later. But just to say, so we have, you know, examples, and these are selected examples, but of customers that are actually using vehicle to grid today and have been earning kind of commercial value, not from sort of subsidized pilots or anything, but from markets, energy markets today. And so this is one of the clients in the demand response program. It's a municipality, and over the course of a couple of summers, and you know, there's probably more recent data to show, but that has been earning $4,000, and this is an important sum of money considering it's with one car, one Nissan Leaf, which is a kind of medium-sized electric vehicle, and a 15 kilowatt charger. So I think this really highlights the real value that can be created already from vehicle to grid in the right places. Just one other example of the services that we operate. So this is New Hampshire Electric Cooperative, also in the Northeast, that's trialing a transactive energy rate program. So this is a rate that changes with the real-time energy costs, and that we are responding to with the vehicle to grid installations on a university campus at Plymouth State University in the US. So based on this, on optimizing this rate, we're saving money, or earning revenues actually for the customer on their electricity bills. In terms of our sort of ecosystem in vehicle to grid, so we are working, as you saw, mainly with light duty vehicles that have been available for years, compatible with V2G today, but we're also working on school buses and other vehicles that are more heavy duty fleet types, and we're integrating with more hardware, hoping to bring a solution to the residential market this year in the US. And in terms of the other components, so we have a platform that's very versatile to integrate via API with the different companies and types of partners in this overall market. So we can work with charger manufacturers via API, or with EV OEMs. And essentially, as I was mentioning earlier, the platform factors in a bunch of different data sources and controls and optimizes the electric vehicles. Right, so I mentioned about demand charge management. So this is one of the kind of more the services that requires forecasting. So we forecast what the peak is likely to be, and kind of keep that updated in a given month for sites, because they have bill charges that are set based on the maximum peak in the month. And this is an example of a vehicle of ours that's responding to a demand charge threshold, essentially in New York City. That was in sort of September, and you can kind of clearly see that when the overall load is going above a certain threshold, that here is around 180 kilowatt for that site, the vehicle automatically starts discharging and kind of keeps the overall site load flat as possible. And then once the load kind of goes back down under its threshold, the vehicles take the opportunity to charge back up again, so that they're ready and their state of charge is made whole. So just briefly, there's quite a few announcements that about Fermata Energy's activities. Maybe just to mention a couple are these, the Inc. Magazine Awards. We're working with lots of different partners across the ecosystem to kind of demonstrate vehicle to grid with them. Yeah, so I won't say too much there. And then a project that's that we're working on right now, actually in the UK, is Park and Flex, which is essentially looking at the potential for large-scale car parks or public car parks that are across the country that have, you know, cars continuously parked there to turn into kind of grid resources for the grid. And we're looking with UK Power Networks and consultancy Baringa and the Greater London Authority at trialing this in potentially an airport in a long stay car park. And the big question here is, so V2G has been tested sort of with fleets and to some extent with residential customers as well. But what does it take for a kind of public, just a person that comes to a parking lot to kind of be willing to give up their vehicle for a couple of hours or for the duration that they're parked for the benefit of the grid? So we're testing out kind of different V2G rewards there. And just to end on a happy note for kind of just general information from the industry, is that we are hearing that more and more vehicles are coming out with bidirectional functionality. So there's, yeah, it's great to see, and adoption as well on the CCS standard. Different flavors here: vehicle to grid, home, building, but also vehicle. Some of these are just vehicle to load. But great, so we're going to all have many more vehicles with the functionality to optimize in the coming years. And then a few examples that are kind of more specific to the US market, but on the fleet side, in the school bus sector and kind of more trucks segment. And essentially, I will stop there. So thanks for your attention.
Thank you, Claire, for ending with this positive note and showcasing how this is not only a reality now, but it is going to be even more so in the very, very near future, with this exponential growth of assets that are going to be connected to the grid and that we need to be able to take advantage from. And we've heard now from market participants what they're doing, what services that they can provide. Now we're going to hear from Hallstein, Hagen, the senior consultant at Nodes. And Nodes is the market platform where these service providers can go into and monetize these resources and provide these services to the grid, where the system operators can go to and purchase these services. Hallstein, the floor is yours.
Thank you very much, and thank you for the opportunity to be part of this seminar. I'm going to take you through some of Node's best practices, but first, one slide on what we do. We're a technology company that has developed a marketplace that allows the system operator to signal where they need flexibility, allows the seller to signal the location of their flexible assets. And as a market platform, we provide a level playing field for all types of technology, including vehicle to grid or any other technology that can deliver flexibility. Through the market, we allow for a price formation based on supply and demand for flexibility, and we allow the grid to reserve and to activate this local flexibility. And since 2018, we've been participating in a number of projects, some of them across EU and some of them national, and each of these flags represent a DSO that we have been involved in. I'm going to focus my presentation today on the Nordflex that is being continued in the Euroflex project, and crucial or central to that project is the definition of this new digital value chain for flexibility. So first, you have all types of flexibility, whether it's production, storage, or consumption. If you're able to control that remotely, you're doing some sort of technical aggregation. To set a price on that and to actually commit to what you can deliver at what price, you need a commercial aggregation. And it's interesting to see how Nuvve is taking a fleet of cars and presenting them to the market. Our role can be then the market operation in a platform, and the system operation and the network operation will act on the buyer side. So the platform facilitates the trading between grid operators and flexibility providers, so that flexibility can be sold bottom up and bought top down. It then allows flexibility from the smallest, maybe also even behind the meter assets, to be available both to local grids or low voltage grids, medium voltage grids or regional grids operators, and to national grid operators. And it's all centered around the common language of location, price, volume, and time. The parameters that we can configure this marketplace for allows us to have a number of products being configured. And these can be different naming conventions in different countries or different parts of the world. The green one, the short flex one, is the activation piece of it. So when you do activation, you can decide to do activation based on price, for instance. The other products that is listed here, long flex, is a reservation methods, and in there you can find many of the products that is described in different countries, fitting into a sort of reservation package. And also a little bit interested from the gray one, which is the max usage. It's a virtual fuse that can be accessed or been agreed between the participants to lower the total use of or total consumption in a period. I said that we're going to touch upon the Norflex, and the headline of my slides here now is that flexibility markets evolve over time. So since January 2021 until March 23, we've been transacting flexibility. We have been operating the market here as a normal market operator, which means we facilitated the matching of transactions. We had been offering a validation and a settlement service to go along with it. It's interesting to see that the smallest order that has been activated is as small as 1 kilowatt, and the largest one in this project has been 5.4 megawatts. We have in this time seen more than 30,000 activations, and we've seen more than 4,000 assets participating. And we have seen the volumes building up according to the time and as more technologies get ready to deliver flexibility. What is interesting in this particular case is that domestic flexibility, mainly from EV chargers, but also some heat pumps and electrical heating, has claimed more than 50% of this market in the period that we've done. So that sort of put the frame that the technology is here to deliver flexibility. The market platforms are here to enable that to happen. The buyers and the regulatory needs to come online to make fully use of this. And I thought I'm gonna put finally as my final slide a bit of what the future could look like. Let's say you drive with your car and you decide that you would like to charge that car at 12:25 in a local area. And when you're putting in the charger connection, immediately the company that is controlling that charger sends a sell order that they can sell now 7 kilowatt of flexibility. They would like to have 200 euros per megawatt for that, and they are located at a grid node which is called LV here, just for the purpose of it. If there is a match, if there is a need from the grid at this point, we will match the two transactions, and the car could then postpone charging with 5 minutes, and it could continue. So the next 15 minutes, it can say, I'm still prepared to avoid charging or delay my charging, and I still have the same price. Again, we could see a match in that time frame. And so it goes on until it becomes necessary for the car to start charging. And then what you do then, for instance, is to increase the price, for instance, to €1,000 per megawatt. By increasing that price, you move down in the merit order for that particular time slot, and you may or may not have a match on your order. If you have a match, you postpone another 15 minutes. But now we're getting close to the time when the user of the car would need the car. So the next time slot, you then decide not to put in an order. And this is something that we can achieve with an automatic system and a digital value chain that is connected all together. Thank you.
Thank you very much, Hallstein, for bringing us this market platform perspective, how you're doing it in practice now. Because of course in V2 Market, we tried to do it, but the regulation was not there yet, and Domie was not able to implement this in real life, let's say. But now I will invite all the speakers back on the stage. We're gonna have a few questions, answer a few questions. Of course, we will probably not have time to answer all the questions that we've received, but I would be more than happy to reply to them all offline, and I'm sure all the speakers will be also more than happy to if you reach out to them to reply to the questions. But I would like to start with one question to all the market participants or all the flexibility service providers, because bringing us back into this regulatory aspect, which is let's say the key aspect for this webinar. What is the regulation, or how does the regulation condition us to provide services? So we've seen already what the implementation, how it is going, but I would be interested in to hear from the flexibility service providers, how is the legislation impacting you? So to rephrase this, what is it that you cannot do right now because of the legislation? And I would ask first Xavier from Nuvve, and also if you can explain a bit, because there was a question on double taxation. If you can explain us what double taxation is to everybody in the audience, and what is it that Nuvve cannot do because of legislation?
So let me start with double taxation. Double taxation is when the electricity is subject to tax, levies, and grid tariff several times. So possibly one time when to use to charge the car, another time to discharge the car into the grid, and then this electricity which has been fed back into the grid can be used by another consumer, which will again pay taxes, levies, and grid tariffs. So then it's even triple taxation. So it takes a lot of the value, although V2X is providing a service to the grid and to society as a whole. Regarding the barriers, let me focus on our experience with the V2 Market project. When we installed the chargers, we faced some hurdles which are not specific to V2X. It's for charging infrastructure. In fact, one of the sites is an underground parking lot, so there was some fire safety rules that at the end of the day, it limits the power of the charger to 4 kilowatts, which is very small power to provide efficiently V2X services. There was AMB is a public entity. There were also issues with the public procurement process of those bidirectional chargers, because there are not many manufacturers of bidirectional chargers. But I think the biggest issue is that V2X is predating the regulation, so that there's nothing in the Spanish regulation mentioning V2X. It has no status, and this creates issues. There's no standard procedure, so it's something new, and there's a lack of regulatory guidance on how to develop pathways for interconnecting bidirectional chargers and for V2G. And what we found out is that, in fact, people are making stuff up. They are imagining things. They say, oh, this is a bidirectional charger, so maybe it's not different. I don't know. Maybe you need a certificate. And And we wasted a lot of time with just things which are imagined, which were not real. And in fact, we could just apply regulation that's applicable to solar, and it worked. But because it's new and because there's nothing in the regulation, people are scared and they cover their back, whether the certification authority, the site manager, even the charger manufacturer. Everyone was a bit worried on what to do. On the positive side, in Spain, you have some dynamic tariffs, which allows to have some implicit signals for V2X. What the regulation could improve is that the thresholds to access the markets are too high. It's 1 megawatt, for example. There's, as you mentioned, Andrés, there's no independent aggregator framework in Spain today. And when we started the V2 market projects, we were hoping from the NSOE accession roadmap that the ancillary services market would open, but it's, as you said, if technically it seems open, in reality it's not possible to access for distributed energy resources. There's no local flexibility market, no capacity market. So that's why we had to downgrade some of the expectations of the project.
Thank you, Xavier. Indeed, a lot to do, starting with the small bureaucracy and red tape requirements that are sometimes very burdensome for service providers. Robert, from your experience in the Mobility House, you've presented a few use cases. What else could you do if regulation would allow it?
Well, in Germany, we suffer actually from two non-existing regulations or situations. It's not just the double taxation, which is reducing profitability of a business case of V2G, but also the smart meter situation. I think Germany, as a very developed country, has the real last place in the row in Europe, and a very, very bad coverage of smart meters. And that is needed actually if you participate in an energy market and trade on a 15-minute base, etc. So that will change beginning of next year, and I hope that will also boost VGI in Germany.
Thank you, Robert. And finally, Claire, you've presented a lot of use cases in the US. What is the European legislation preventing Fermata from doing right now?
Yeah, I don't think there are necessarily barriers that would prevent operations altogether. Legislation is generally moving in the right direction, including under the influence of this group. So yeah, vehicle to grid is being done kind of in the UK and France and various places. I think something to facilitate it, well, a couple of things maybe to facilitate would be to improve the connections process, just grid connection process and agreements that the DSOs provide to kind of maybe be more specifically adapted to the needs of a vehicle to grid, rather than having to use, for example, in France, like solar export agreements and kind of fit V2G under those. So maybe just being more explicitly allowing vehicle to grid export. And a bit related to that is probably the development of dynamic rates that also encourage not just self-consumption behind the meter, but also consumers to kind of export energy front of the meter, because otherwise there's a big limitation to kind of staying behind a residential load, which individually is quite low and small, whereas the resource can have potential to support the grid much beyond the individual home. So,
thank you. And now to move on to the, let's say, like the bigger picture, like the European perspective in general, rather than the individual member state. Hans and Hallstein. Hans first. So this project is very much focused. V2 Market is focused on Spain, of course. Where could Spain learn from in the EU or outside of the EU, from your perspective? What should be the reference point for a country to develop V2X?
Well, that's not an easy question because we see that different member states, countries are more advanced on different topics. I think one of the main elements that has been discussed is this independent aggregation framework. On one hand, one could look at France, that has, well, it's quite advanced, although it's also not perfect yet, because it only allows you to do load reduction rather than enhancement, which is also necessary, of course, for storage. GB is developing quickly also on that aspect, actually. So maybe also looking at GB would be, to Great Britain would be relevant in that aspect. But that's not the only aspect as explained. Yeah, so I would really encourage all attendees to read the report, because that will in detail show which of the aspects, which member states are most advanced, and where well, a country like Spain maybe could get their best practices from.
Thank you, Hans. And indeed, also to build up on this, in the framework of V2Market, we're also going to present at a later stage a report also analyzing these barriers and how we can overcome them, particularly for the case of Spain, but also where we can learn from the rest of Europe. Hallstein, there was a question in the chat that I think is quite interesting, and I think you're the best one to address it. From your experience beyond Norway, what are the system operators that have created the framework, or where they have the framework to procure market-based flexibility? From your experience, where across Europe do you think this is there's the right framework for a market platform like Nodes to be active in?
It's again a slightly difficult question, because people are buying flexibility in different shapes. So Hans mentioned UK. In the UK, we have seen large volume being reserved, maybe once or twice a year, to be activated, but not so much activation in the market. And in the Nordics, we've seen more activations taking place, so more sharp in terms of where it goes. So I would actually say that in our experience, what we see from the Nordics is a implementation of this digital value chain, which is come very far. So for instance, when one of the DSOs open a new city for buying flexibility in that city, the next morning there were 900 assets that asked to be approved. And that was without exchanging any other information than listening to our API. So I think there's different ways of seeing how you can do it. The important thing is that the DSO starts buying flexibility, because the biggest hurdle I see is that without the buyer, we don't get all these innovative sellers on the market. So it's important that the DSO starts buying flexibility and starts experience and learning from the technologies that are available. So I guess that's the question, answer to that question.
Thank you, Hallstein. Indeed, a perfect message to end. We need also the system operators, the buyers of these resources, to open up and to access these assets that are, as Hans was saying, the low-hanging fruit almost. There's one question that I want one of the service providers, flexibility service providers, to answer, because this is a recurring thing, not only here among experts, but also with the regular consumer, a conversation that I have with my family and friends over dinner. Is there any risk that through V2G, I grab my car and it's completely depleted and I cannot use it? Who wants to answer this question very quickly before we finish? Xavier?
There's no risk because the user is always in control, and the first priority of the V2G operator is to ensure that the driver will have enough battery for his driving needs. So there's always the possibility to set a minimum state of charge that you want to be kept at all times, for example, 20% or 100 kilometers. And there's always the possibility to trigger a charge, an instant charge at full power, just by pressing a button on your app.
Perfect. Thank you for the very concise answer. There's no risk, and we should move away from these fears. I think we're reaching now the end of the time that we have. As I mentioned, please reach out to the speakers, to me. I saw a lot of questions of data exchange standards. I can answer them per email. But thanks a lot to all the speakers today. It was a very informative session. I do have to ask another favor from our audience. This in the next slide, a QR code that you can follow. This is a QR code that will lead you to a survey that we're conducting within the V2Market framework to understand what are the concerns, issues that electric vehicle owners, that aggregators, that municipalities, that all the actors involved with V2X could have. So please, if you have 10 minutes, follow the survey, and you will help us greatly with this project. Now, just to finish off, this is again a series of webinars, as I mentioned before. We will, over the next couple of months, have 3 more webinars. One will touch on the topic of or the specifics of the Benelux market. So, what is possible for Belgium, Netherlands, and Luxembourg on V2X? Innovative solutions. We will see a lot of interesting business proposals. The second webinar will be on local authorities. What are the opportunities and challenges that municipalities, local authorities, fleet managers within these institutions will face over the next couple of years? And the final webinar will be on the specifics of buildings. How can electric vehicles be an asset to a building through vehicle to building, providing services to the building in itself, facilitating the integration of renewable energies that the building might generate, and so on. So I want to just close this with the 3 bullet points, or rather 4. Based off what Hallstein was mentioning, which I think is a very nice way of finishing. Flexibility service providers are here. We've seen this. They're ready to jump into action. Market platforms are also ready to provide the platform for trading and purchasing of flexibility. What we need are system operators and the regulation to follow up and to catch up with what the market is ready to provide. And yeah, I think these are the 3 points. The last one is that we see very positive developments. We see the consumer interest. We see new electric vehicles joining with V2X capabilities. We just need to take advantage of that. And with that, I wish you all a very nice continuation of the day. Thank you, everybody, for joining us. Thank you to the speakers for joining and providing their input. And I hope to see you all very soon in the next series of the V2Market webinars. Thank you and goodbye.